In this video, I am going to solve this second order homogeneous differential equation. It has constant coefficients and the roots are repeated. And the differential equation that we are solving is this: 4y double prime plus 12y prime plus 9y is equal to 0, with the initial conditions y of 0 is equal to -2 and y prime of 0 is equal to 4. So our first solution is going to be of this form: y of t or y1 of t is equal to e to the power rt. Okay, and that's our assumption. And then we can find the first derivative of it: y prime y sub 1 prime is equal to r times e to the power rt, and y1 double prime is going to be r squared times e to the power rt. And now we are going to take these values and plug it into this equation. And I'm going to do a little bit of algebra. So if I do that, I get the following. So I'm going to get 4r squared plus 12r plus 9 and multiply it by e to the power r times t. All of it must be equal to 0. Here all I have done is basically plugged in these values and then just factored out e to the power rt. Now e to the power rt, that cannot be equal to 0. As you know, it's an exponential function. It's always going to be over 0 if the exponent is positive or negative. It really doesn't matter. So now if e to the power rt is not 0, then the other factor must be 0, which means that this has to be equal to 0. So 4r squared plus 12r plus 9 must be equal to 0. So 4r squared plus 6r plus 6r plus 9 is equal to 0. Now between these two, I could factor out 2r. That's going to give me 2r plus 3. And between these two, I could factor out a 3. That's going to give me 2r plus 3. And that is all equal to 0. Now I have 2r plus 3 times 2r plus 3. As you can see, the roots are repeated. The factors are repeated. So if 2r plus 3 is equal to 0, my r is going to be -3 over 2. So the second root is also going to be r is equal to -3 over 2. So my y1 of t is going to be e to the power -3t divided by 2. Now we know from our knowledge of solving these types of equation where the roots are repeated that the general solution is going to be y of t is equal to c1 times y1 of t plus c2 times t times y1 of t. As you know, this introduction of t makes the solutions linearly independent. So let's go ahead and plug in the values. So my y of t is going to be equal to c1 times e to the power -3t divided by 2 plus c2 times t times e to the power -3t over 2. Now I could go ahead and apply the initial condition. Y of 0 is equal to -2. So that's going to give me right away -2 is equal to c1. This term is going to vanish because of t, presence of t, because t is equal to 0. So that's one coefficient. Now to find the second coefficient, c2, I have to take the derivative of y. So it's going to be y prime of t is going to be equal to -3 over 2 c1 times e to the power -3t over 2 plus, now for this one I have to use the product rule. So the first one is going to be c2 e to the power -3t over 2 minus minus is coming from taking the derivative of e to the power -3t over 2. So it's going to be 3 over 2 c2 t times e to the power -3t over 2. However, it's given that y prime of 0 is equal to 4. So it's going to be 4 is equal to negative 3 over 2 times c1. And this is going to be just 1 because e to the power 0. Plus, again, e to the power 0 is 1, c2. So if I solve for c2, I'm going to get 4 plus 3 over 2 times c1. Now I already found c1, which is negative 2, right? So c2 is equal to 4 plus 3 over 2 times negative 2, because c1 is negative 2. That's going to give me 4 minus 3 or 1. So my c2 is equal to 1. Now my final solution is going to be y of t is equal to c1, which is negative 2 e to the power negative 3t divided by 2, plus c2 is just 1, right? So t times e to the power negative 3t over 2. And this should be your solution to this differential equation with the given initial conditions. I hope that this discussion was helpful. Thank you very much.